be able to, we'll wait for more folks to come in, but you should be able to also type in the chat window there. I'll mention this a couple times. But let me know if you can hear me. I think that's the first thing. So if you could just type something in chat, that'll let me know that you can hear me, and we'll be able to kick things off shortly. Perfect. Excellent. So Eugene is also going to be joining us. So what I'm going to do, yeah, I'm just going to wait for 1 or 2 more minutes, and I think we can get started. I definitely want to dive into some fun stuff, and it's okay if some people end up missing the beginning. So I think actually a good starter question in chat. I would actually love to hear what you guys are most interested in, because I mean, I'll talk about this in a sec, but basically I was gonna talk through some stuff and then basically try to focus the last bit of it on mostly live coding. So yeah, that's more or less what we're looking to do here. So anything that you guys are curious about, you guys are interested in doing, let me know. That's more or less where I want to be. So feel free to type that in while we're waiting for some more folks to join. And I believe Eugene will be joining us, if not right away, then certainly for the live coding, because he's the one who's going to be doing most of it. If you want to jump ahead, feel free to go to studio.nearprotocol.com and play around. So what I'm going to be doing is a little bit more of a traditional presentation. That I'm going to walk through some studio stuff and just point out some of the features and things like that, and then we'll do some live coding, which will be Eugene, who I'm going to make sure that knows is. There we go. All right. So what I'm going to do here, I'm going to start sharing my screen. I'm going to kick off a presentation. So let's do that. Do Google Chrome, share that. So I think you guys should be able to see that. Should be able to see that plus my little face there, which we may or may not turn off. So, all right. Hey, Eugene. Oops, we're at the wrong side. We're giving it all away. Oh no. All right, back to the beginning. All right, let's kick things off. So welcome, first of all. We have people from all around the world, actually. So some folks certainly from New York, Austin, Denver, San Francisco. I don't actually remember all the places that we had posted, but then some folks I know are international as well. So thanks a lot for joining, first of all. And just a quick taste of the goals for today. What I want to do is just give you a taste of what are decentralized apps, and also show off a platform that you can use to create them. So part of this is about kind of building the mental models for what it actually means to build a decentralized app. Part of it is actually seeing it done, and part of it is shouting things out to Eugene to to build on your behalf. So basically my assumptions about you are that you're roughly familiar with blockchains. You may or may not have actually built stuff on them. That's fine. You may be a developer. You're probably a developer, but you may not be. That's also fine. You can follow along and play along, or you can just sit back and watch. It's totally up to you. So as a number of you have already discovered, we do have chat available. So feel free to put things in the chat window. I'll try to check that periodically and just make sure that we're in good shape and I'm caught up. Otherwise, I'm just going to kind of walk through things here. So, in terms of goals for today, so basically what I want to do is just briefly start off by talking about just apps in general, decentralized apps in general, just get everyone kind of up to speed and make sure we're all on the same page. Then I want to do just a quick discussion about what your protocol is as a protocol that you build dApps on top of, and then we'll actually get into the good stuff, which is live coding, showing off how it actually works and things like that. So by the way, I also want to plug our Discord. So if you're interested in joining Discord, we're not hosting this this webinar right now on Discord, but this is where our team lives. This is where our community lives. So if you're curious and you're interested, just go to near.chat. Super easy to remember, and you'll be able to sign up for our Discord channel. So who am I? I lead operations over here at Near. I used to lead a company called Viking Education, which was an online software engineering bootcamp program that did full-time and part-time programs. And previously, I worked and created the Odin project, which was, I guess, probably 6 or 7 years ago now, which was an online open source community for learning web development. So I've been in education for a very long time. Eugene, who's sitting next to me, who you guys will see shortly, is a senior software engineer. And he's got a long history of competitive programming, gold medals, or gold medal. Why did you only win once?
It's tough.
You also worked at Google and Facebook, so you'll hear from him. You'll hear from him a little bit later. So yeah, let's just dive right in. Actually, let me just quickly check in on the chat, make sure everything looks good for you guys. Yep. Okay, we have some questions, and great, cool. So let's just keep it going. All right, what are decentralized apps? So just to get everyone on the same page, the whole idea of a decentralized app is that it runs on a whole distributed system of servers rather than one. It has multiple points of failure rather than one, or I guess you could say it has multiple redundancy points. And basically, as a mental model, if today's applications are mostly deployed to the cloud, which the cloud is really just a bunch of commodity servers sitting in the server farm somewhere, probably in Washington or somewhere with cheap power. And the alternative is if you're thinking about something like a blockchain, which is running in a decentralized fashion, each one of those commodity computers is more or less run by some random human around the world. And that's probably the easiest mental model for understanding the difference between what a centralized app looks like when it's deployed versus a decentralized app. And of course, a lot of the challenges on building platforms for that are how do you enforce some of the things that you take for granted in a fully controlled data center among people who are all around the world who may or may not have good intentions and things like that. Luckily, that's our problem, not your problem. All you have to do is learn how to build on top of that. So one thing that's just worth checking in on is just why decentralization? Why should we even care? And I think that there are really two ways of looking at this, or two lenses of looking at it. I think one is the zoomed out, the abstract, which in a lot of ways is stronger but less easy to hold on to. And so people talk about censorship resistance a lot. I think there are a lot of different angles that you can look at from that. One of the most tangible for you as a developer is that if you build on top of someone else's platform, like for instance, you can think of the case of Zynga. Zynga built on top of Facebook. They built an enormous business very, very quickly on Facebook's platform, accessing Facebook's data, accessing Facebook's users. And then as soon as they got too big, Facebook just pulled down the hammer, and then their whole business just got destroyed. So that happens a million different times in a million different ways around the world on different platforms. And that's one of the actually easiest, most tangible ways of thinking about the benefits of decentralization and not basically being tied to a specific person's platform or a specific company's platform for their data and things like that. The other one is this idea of trustlessness, which is that once you actually have something that's decentralized, once you're operating in a decentralized way, it allows you to change your trust model as well, because you're no longer having to trust a single entity, which is a single point of failure, which could, has a single honeypot that could be hacked and things like that. And so it changes a lot of the ways that you think about, what makes sense to send money, send data, send things like that. Those are relatively abstract. So I like to zoom in on the concrete as well. And there are a lot of different ways of looking at this. Another way that I like to look at it, which we're not really going to cover here, is this idea of primitives. But if you kind of break it out, one of the core ideas is self-sovereignty, which means that actually, specifically when you're thinking about blockchain, the blockchain version of decentralization, is that now you actually own everything. You own the money that is tied to you, you own your data, and you own the assets themselves. That means you own them, not they're not stored on some company server somewhere at their permission. And so if they blow up, then it's gone forever. There's also this idea of digital uniqueness, which is great, which is sort of this idea of if you understand Bitcoin, the whole idea of Bitcoin, what makes it amazing is that now a single Bitcoin is literally there's only one in the world. It's a digital asset that you actually can't just sort of copy and paste somewhere else and create two of, because obviously it wouldn't work if you could just create two pieces of money. And so the innovation that they used to create Bitcoin defines this idea of digital uniqueness, and now we can actually deploy that into other ways. We can extend that, and we can do things like what CryptoKitties did with these cats, for instance, as a crypto collectible is kind of just the toy version of a very important concept, which is that you could store things on the blockchain that actually represent very unique objects, which is something we've never had before in the digital space. And then, of course, on the transactional side, you can actually, because it's peer-to-peer, you can trade these, you can move these assets. You can move them between you and another peer. You can do them, and so the directness of that is actually a very important thing, because normally if you're trading something digitally, you have to go via a server. And again, there's that single point of failure, there's that censorship aspect, and honestly, it also slows things down when you put a middleman in the middle, and somebody's usually collecting rent. And so there are all these reasons why it's actually really helpful that you can now transmit these assets between two parties. And another thing worth noting on the self-sovereignty that I didn't talk about is that devices can actually be self-sovereign as well in this world. So you could, for instance, your refrigerator could actually have ownership of its own data and its own money and its own assets. So it's just something to think about as you look forward. So in terms of just starting to look into the actual behind the scenes, under the hood stuff for how do centralized apps work versus decentralized apps, if you're familiar with the centralized paradigm, you have a browser that's getting information and sending information to and from the server, which is then talking to a database on the lowest level, and then somehow the front end has to actually get served in the browser. So you have the HTML and the CSS and all of that. A lot of times those are actually hosted off to the side somewhere in static hosting. In the decentralized world, you still need to display the web page. So it's still kind of being served from the same front end. You can actually serve it in a decentralized way, but at this point, it's not really where we want it to be. The difference is really on the back end, which is that your browser is typically talking directly to the blockchain itself, which is running a smart contract that then is sort of interfacing with or rather that is running on the blockchain network. So that's the key difference, is that the blockchain actually sort of takes over both the server, which is doing compute, and the database, which is doing data storage. And I'll peek into this a little bit deeper. So I generally like to approach things in terms of key mental models. So, it's what are the things that you need to really just kind of keep in your head that's a little bit different about the way you would probably by default understand the world. So there are four that I just wanted to cover really quickly here. One is that data actually lives on the blockchain. Two is that wallets is basically just talking about wallets and the idea of keys and ownership. The third is interfacing with servers and databases being different than interfacing with the blockchain itself. And the fourth is that code is actually immutable on the blockchain as well. So the first one, data actually lives on the blockchain. So the difference is that when you think about how data lives today, it's basically, it exists in a database owned by a company somewhere, and that company is the one that's basically deciding when and how that data gets modified or moved, or when your number of tokens or whatever it is increases or decreases. Whereas in the blockchain world, the data is actually stored on the chain, and this chain is this public layer of data. It's a public database that's distributed all around the world, and it's kind of this pool that's shared all around the world. And effectively, the data that you're talking about, even though oftentimes we sort of refer to it as being yours and being in your wallet or something like that, it actually lives on the blockchain, and it's effectively tied to you via a cryptographic key. And what you own is the key. So it's almost like the blockchain is basically just a bunch of safes, and you own the key to one of those safes. And that's basically kind of a mental model I like to use to think about that. The second one is wallets and keys, which is actually, I guess, zooming into the same idea. And again, the idea is that this data is tied to you via a private key. And if you want to actually modify or move that data, you have to send a transaction, and that transaction has to be signed by you. And typically that actually occurs inside your wallet, and your wallet is basically just a way of holding those keys. Oftentimes a wallet serves two functions. Oftentimes the wallet will actually be the interface point with the chain as well. But so it's basically going to be when you want to do something that touches the chain, an application will request permission from your wallet, which will then sign the transaction and send it to the chain on your behalf. And so that's also a key mental model, and something that's new about working with dApps and blockchains is that you have this idea of the wallet, which has to sort of do things for the user. So it kind of adds a step. The wallet in some ways strangely acts almost like a server sometimes. I won't get too deep into that model though. The third one is that the difference in how you access the chain is worth thinking about, because this actually can sometimes take a little bit of time for beginners to get over the idea, which is that, of course, when you're interfacing with a database in Web 2 world, it's basically the servers, you sort of make a stateless request to a server, which is then hooked into the database, and it runs that request. And it's like a pretty basic sort of thing. On the blockchain, it's different because the chain is actually made up of all these nodes that are all spread out everywhere, and they have to be synced up together. And the only way to inject it, you have to inject a transaction into that network, into that mesh network, which basically means that in order to do that, you have to talk to one of those nodes, which represents the network. And so that might be you running a node in your local browser, or it might be you sending a request to an API that you trust, which they themselves are running a node on that chain. So just in the way that you kind of think about how you're interfacing with the chain, you always have to think about where is the node that's going to be submitting those transactions on my behalf. And a lot of the time, that's actually occurring in the wallet. So, if you're building an app that interfaces with wallets, a lot of times the wallet is the one that's kind of doing that. But it is something that you do have to think about, which is different than Web 2 world. The fourth one is that code is immutable. And so basically the idea of that is we're so used to, one of the nicest things about Web 2 world is that you push code to a server, and then the very next request, it's running the new code. So it's great. I mean, it's incredibly fast, iterative, and changeable. But one of the whole points of the blockchain is that it's actually immutable. Is that you shouldn't. The whole idea is that you shouldn't allow the developer of an application to have disproportionate control to then change a bunch of stuff on your behalf. Like it wouldn't be censorship resistance if that wasn't a property. So unfortunately, what that means is that typically when you push code to the chain, you can't change it. And because if people start using that code, and for instance, if you were to change that, if they put a bunch of money into a contract, and then you could change it, that would be a problem. So that is one thing that we need to kind of keep in mind with how the blockchain works as well. So there are a lot of hacks and workarounds, and we're basically trying to kind of get towards the happy middle ground of how do you make the code that you've deployed changeable up until a point, and then maybe you lock it, and then people feel comfortable putting their money into a contract or something like that. But it is an important difference. So in terms of what are the pieces of a decentralized app, so you as a developer, what do you have to build? Well, you have to build a front end. That's pretty standard. The key bits are actually the middle two, which is your front end needs to have a library, which an SDK, which knows how to talk to the blockchain and interface with the smart contract, which is effectively what you can consider to be your server-side code. And the smart contract is the code that actually gets run when you submit a transaction on the blockchain. And so the way these chains work is every node actually is running that code on your behalf. So when a user clicks a button on the front end, it runs a JavaScript method in your JavaScript library, which then knows how to talk to the smart send a transaction, usually via the wallet, to the smart contract, which is then going to run on a whole bunch of nodes at the same time, and the chain does its magic, and it changes some sort of state typically. So I wanted to talk about, actually, let me pause for a sec, just in case I'm just going to check in on chat real quick. I am going to be recording this, and well, I'm at least going to be sharing slides. We'll see if the recording is actually shared. So yeah, we'll see what happens there. So I wanted to jump into basically like, what do we do as a blockchain? So there are a whole number of blockchains out there. You've got Ethereum. It's kind of the original gangster. They were the ones who've essentially figured out how do we take the Bitcoin technology and put a computer on top of it, or put a virtual machine on top of it, and allow people to build these applications on top of it. And unfortunately, they're quite slow, and they're kind of a sort of an obsolete technology with a wonderful community. And you also have other chains, like there's Tron, there's EOS, there are a whole bunch of ones that haven't launched yet. And ultimately, what Near is also a scalable, developer-friendly platform for building these decentralized applications, which is running on a blockchain. So one of the key differences with Near is it's designed from the beginning both to scale and to deal with usability. So that means usability for you as a developer and usability for your end users. So one of the reasons why we're actually building this, which I think is actually an important thing to cover really quickly, is that this ecosystem is still super early. So I don't know, maybe you're here because you're sort of already deep in the ecosystem and you're curious to try out something new, or maybe you're here because you're from outside the ecosystem and you're interested in how does it work. But I mean, I think everyone can really see that even though there was this huge speculation and hype and things like that last year or the year before, we're really still super, super early in the technology. The only people who are really deep into this are the innovators. These are the people who speak very technical languages, who understand the guts of how these things work, and who are willing to go through a whole bunch of crap just to produce an application on one of these. Unfortunately, there haven't been a lot of users. Some of the most popular apps on the chains have literally dozens of users. And we haven't gotten to the point where there are more people using the chains. And until that happens, it's just not going to be a successful ecosystem. So it's really important to figure out how do we actually bridge the gap from these incredibly technical people who are willing to go through a lot of hell to use these applications and and as developers to build these applications, to people who just want to make shit that works, who just want to use something that they don't care if it runs on blockchain. And really what it comes down to is there are two problems. There are two core problems. So one is the demand side and the other is the supply side. So on the demand side, well, actually, maybe it's worth starting from the supply side. A lot of blockchains have talked about scalability and this idea that what happened with Ethereum is there have been a few times in the history of Ethereum where it runs rather slowly, and so when an application on it gets very popular, all of a sudden the whole chain just grinds to a halt and nobody can do anything. So there are severe scalability problems. But the other side is that you only need to bother with scalability if you can actually get people using the chain. And a lot of the issues that we run into are that the existing paradigms for building applications on these chains require you to ask a lot of your users. So it requires you to ask your users almost as soon as they, in the Ethereum ecosystem, and EOS actually, almost as soon as they drop into an application, you have to, you confront them with, do you have a wallet? Let's use your wallet. Oh, do you have tokens in your wallet? Well, we need to access your tokens. And if you don't have any tokens, you have to go to the exchange and you have to buy a bunch of tokens and you have to fill in your passport number and you have to put in your credit card and wait 7 days and all this stuff, right? And this is, for usability 101, this is a pain in the ass for everyone involved. So until we begin to bridge some of those usability gaps, it doesn't matter how scalable the chains that we build are because nobody's actually going to come in and use them. So we need to solve actually both of those things. The whole point of this platform is that it's built with a mindset of usability first, scalability to support that. And so there are things that you have to do that you can do on the protocol level that now we know about that we didn't really have any idea about 2 or 3 years ago when these platforms started coming out, which allow us to make the experience of a user using an application feel a lot more like Web 2 world, old world, as opposed to this inconvenience them at every possible corner, which we're doing with Web3 world. So, on the scalability side, we use a sharding approach, which is reasonably similar in spirit to what the Ethereum 2.0 proposal is. So if you're familiar with that, it's kind of where Ethereum is trying to go, but it's taking them a long time. And we're doing something that's reasonably similar spiritually or in theory. And then on the usability side, there are things that are focusing on end user usability and things that are focusing on developer usability. So for end users, basically, can you get them to use an application so they don't have to deal with wallet stuff up front, so they don't have to deal with owning tokens up front? And from a developer perspective, can you actually write these smart contracts using languages that you're familiar with? Can you, can you do things on behalf of your users so that you don't have to bother them every single time you want to ask for permission to do things? So ultimately, all of this kind of ties together into more or less like common sense. It's like making common sense decisions. The principle of least surprise. It's like you as a developer should be able to look at this code and like kind of figure out what it's doing and kind of figure out how to use it. And that's basically our goal. So hopefully that's going to happen tonight. As far as where the platform is right now, so we have our developer net released. So we have one, you can download it and run it locally, or you can run it in our web IDE, which we're going to show off. And we have a hosted node that's essentially running in the cloud, just as a way of, as sort of an endpoint that you can build applications against. So if you can see the animation here, I mean, I'll show this off, but basically what this is showing is the online IDE that we have. And basically what it does is it allows you to build and deploy an app really easily. So you can go there, you can jump into the code. We have templates that are already available. And basically, I'll show you this in a second, and Eugene's going to go super deep. But the whole idea of this is how can we get you to try stuff as quickly as possible? How can you test things, break things, all of that as quickly as possible? So we have a whole bunch of applications that people have built. It starts with toys, right? So if you're familiar with the Reddit Place app, we have a Near Place app, which is sort of a collaborative. If you want to go to the URL, you're welcome to play with it. It's a collaborative app where different people from around the world can poke the same pixel, and everybody can sort of create things simultaneously. And that's all built with a blockchain in the back end. We have a meme generator. We have we ran a hackathon, or we were one of the prize leaders in a hackathon recently, where we had some apps that came out, including one that was basically about blood donations. We had another that was about saving pinky promises to the blockchain, because once you save something to the blockchain, it's immutable. So right, it's like a pinky promise. And we've had some to-do apps and things like that. So anyways, there are a lot of interesting toys that you can play with so far. We have documentation available at docs.nearprotocol.com, but you don't care that much right now, because probably you want to actually see what this stuff actually does. So what I want to do is first, I'll share my screen. Well, I am sharing my screen, but I'll show off sort of the basics of what Studio is doing, and then turn things over to Eugene, and he's going to dive in a lot deeper and give you guys a chance to probably shout out some stuff. I don't know exactly what the plan is, but we'll see. So the first thing that I wanted to do was actually just go over to Studio. So I don't have anything in particular planned right here, but what I want to show off is, let me go to the guest book. And I don't know, I haven't cleared. So basically we have these templates, and the idea is that you hit create. And what this is a smart contract plus a front end. And so you don't, if you were doing this on your local environment, like, you wouldn't necessarily need to have your front end sitting right here. But we're trying to make things as easily as possible. So actually, before I explain even what it's doing, I'm just going to run it. And hopefully this is gonna show you the interaction. Oops, where am I? Let me kill that.
This might be slow.
It's going slow. Well, go figure. So instead, actually, I'm gonna hit run and then just hang out in here for a second. So what I want to do is just walk through what it looks like. So what are all these files? So well, we have the guest book. So this is basically just a chat app. And so what it does is I can log in with my wallet. So we have a hosted wallet. So right now we've jumped over to wallet.nearprotocol.com. And I've already signed up. So if you haven't signed up, you would actually be asked to input your username. But I'm actually going to authorize the app to use this account. And so what you guys can do if you want to is you can literally copy this URL, and you can go through the same flow. I just pasted it in the chat. You can go through the same flow, and you can post messages. So I don't know what you guys want to post, but you're welcome. I don't know if I should leave this as an unprotected endpoint right now. But hang on, this menu is actually. So I'll check back in on that in just a sec. But so basically, what are the pieces here, right? So this is an IDE, and what we're looking at, main.ts, this is your smart contract. This is actually what's going to be deployed to the blockchain. So what this is this is the code that's going to be run by every node that's in a particular shard. Or I guess for the simplicity, you can just think of it as every node is going to run this code at the same time. So this is your smart contract, and it's written in TypeScript. So if you have any familiarity at all with either JavaScript or C++, I mean, it's super, super easy. It's more or less JavaScript with types. And we've sort of restricted a couple of things because it has to be fully deterministic, but you also don't have to care about that. In the end of the day, this is just code, and you're probably relatively familiar with what this looks like. I think the key bit is, number one, it's basically just JavaScript. Number two, the object that you interface with, it's this global storage object. This is actually how you write things to the chain. And Eugene can go into the details of it a little bit more, but I just wanted to highlight that global storage is more or less your window into the chain. If you're familiar with, I mean, it's, you know, it's like storing cookies or interfacing with nodes, interfacing with storage in Node. You know, it should be a familiar paradigm to save stuff to global storage. And so basically what happens is, you know, the function gets called it on the blockchain. You know, this contract it gets spun up, it does its magic, it interfaces with the chain, and then it gets shut down, almost like a web server. So, I mean, the paradigm, if you're familiar with web, is not that hard to understand once you get over the mental models. The other side of what we have here in the studio, in these templates, is we have this SRC, which is basically just a front end. It's super simple. There's nothing, you know, there's no magic to it. It's just an HTML file. We have our main.js file, which is basically your front end JavaScript. And that's more or less it. Eugene can talk about the details, but I think the other thing that I wanted to note was that we also have tests. So in a lot of these templates, we have tests where you can basically, you run the test button and your front end tests are also going to run in the browser. So we'll see, give that a second because it sounds like things are. So right now, if you want to write tests, if you've worked with Ethereum, I think you'll understand how different this is. If you're not familiar with Ethereum, you might say like, oh, this just makes sense. That's kind of the goal. So basically what happened was there were Jasmine tests, and it was all kind of deployed in one big package, and we've run the tests, and you know, now we have green. So it makes it super easy to write tests, run tests, and that's it. That's kind of the whole point. So we have a front end down here which gets deployed. Again, I'll hit the run and go check that out. So what we're doing basically right here is we're deploying the front end to app.near.ai, which is sort of like GitHub Pages. It's just a hosting site. Oh hey, I see you guys have been playing with this. So yeah, it basically, we have your front end hosted on app.near.ai, and then all the smart contract has been deployed to our DevNet, which is our blockchain. So every time I'm typing a message here, hey, this is on the blockchain now. So this is literally, it's going through, it's running a JavaScript method that then goes and interfaces with the smart contract on the chain, runs the smart contract method, and it's basically polling it to see what the response is. That's it. So I think that's probably conceptually all we need to get out of me. Is there something you guys want to build? So if there's something that you want to see Eugene build that you're curious about, feel free to throw that in the channel, or you can actually throw it in the guest book. Because I think he has something that he wants to build here. Eugene, let me promote you to a panelist here.
By the way, there's two types of chat.
There's two types of chat.
So like one of them is public and attendees can see it as well. And I see Eric has a lot of messages in like only panelist chat.
Oh.
So just
to all
isolated.
Oh, interesting. Okay. So let me jump over to my Zoom. There we go, participants. So just give me one sec, guys. I'm gonna promote Eugene.
All right.
Congratulations, sir. You've been promoted to a panelist.
Okay.
So what I'm gonna do is mute myself and actually answer a couple questions while you're. Okay. If you want, you could share your screen, and maybe I'll just keep talking for a sec. So question I see is testnet ready? So I think the real question is define testnet, because everybody out there defines testnet in a very different way. So I think probably the pure way of defining testnet is the exact same network as mainnet, only it's not mainnet, it's a testing environment. Almost nobody who's actually claimed to have a testnet actually defines it that way. So there are a few release stages on the way to testnet. So the next one is to be running a multi-node test devnet. So we call that AlphaNet. The one after that is to add economics. the one after that is to add economics. Basically, the multi-node stuff is going to be coming out in just a couple of weeks, or not even that. It's probably about a week. And then moving into economics, the economics will be coming out shortly thereafter. And so yeah, at that point, you can already build applications. At that point, you'll be able to build even more in-depth applications, and everything from there onwards is just gravy. So anyways, I'll turn things over to Eugene. I'll stop bothering you guys, and yeah, what do you got for me?
Hey, can you hear me? I guess. Okay. Okay, so you all played with the near guestbook, and I want to dive a little bit more with another example first before we start building something. Either on request, or I have an option to build a polling app. So the idea you will be able to vote on the chain, so that should be fine. So flow that happened when I sent a message. Okay, sure. I think I lost the guestbook now. Okay, let me pull the chat real quick. Oh yeah. Chat. Okay, I got it. All right, so this is how it works. So when you post a message, we can actually jump to a console and network and see what's going on. So let's say I say hi. So what happens is we do the following thing. We basically submit a transaction that at the end gets to the chain, and later we record it on a smart contract. But before, what happens is we have a wallet that embedded as part of the application. So it's embedded using the iframe, and this iframe contains a wallet that primary feature is just a JavaScript that subscribe to a message. So JavaScript. So this wallet iframe holds your keys in a local storage. So the application doesn't have access to this. But when the application wants to send a message, what it does, it creates a transaction that later sent to this iframe through in-browser messaging. And this transaction is validated by the wallet, and it checks that this comes from the right application with authorized token. It is directly to a contract that a wallet authorized to use for this particular token, and it verifies that the transaction is not monetary, which means it doesn't take tokens out of your account. And after we did this, we assume the transaction is not going to harm a lot, and we can automatically approve this. So when the wallet approves the transaction, it actually signs this transaction with your private key. And then it sends the transaction back through the messaging app to guestbook. And this guestbook app is now have a signed transaction, which it sends to a DevNet. And once a DevNet received a signed transaction from your account, it can actually process it properly. So as part of the code, what happens is we create a new message, we assign it an index that is a next index of number of messages, and we update the global storage. So I want to start a slightly simpler version than a guestbook, which also has a wallet integration, and we can go first with some details there. So this is one of the templates, and let me actually try it. Deploy. So this template is pretty simple. It has two functions. It's saying the last person who said hi, and it also allows you to authorize with near. So when I do authorize with near, it asks me to log in and authorize the app. I do this. Now it has my account ID, and you can see on the top you have a token. And this token lets application to use my local wallet, or the account stored on my local wallet. So when I say hi, again, the wallet signs the transaction and it's sent to the DevNet, and here you can use it. So let's go to a contract to see what's going on here. So contract has two functions. One is what we call a change method. This method can modify the state while it doesn't return anything. And the second method is a view method. It doesn't know the account who sent this message or like who called this method, and it cannot or shouldn't modify the state because it will throw an error if you try to modify the state. So first method is say hi. So this is what happens. We have a contract context which contains information from the current transaction that was sent to this contract, and it contains the sender. So this is the account ID of the previous sender who called this contract. In our case, it's our account, so the person who called is going to be my account. Then we have a login function. So login is just plain simple logs that we do not store on chain, but later you can debug it. So whenever I send a log, so here it is. It's saying this contract logged Eugene said hi, says hi. So this is how it works. So it used the sender, it just concatenated two strings and logged it into console. So whenever I call this function, I personally can read these logs, but also everybody on the chain can read this log for this particular transaction. So then what we do, we use a global storage object. So global storage is a persistent storage. It's a helper class, and it has some functions like set item. It takes a key, which is a string. In our case, it's a fixed key, last sender, and it takes a value. In our case, it's an account ID. Account ID on our system is also a string right now, and it just stores the string here. Then we have a view method, which is saying who said hi, and it just retrieves this value by the key. So what's interesting here is, even so it's called global storage, it's a storage for this particular contract, which means if you would deploy a different contract and use the same key, you will have a different storage for this key. But for this particular contract, next time it executed, it will have the same value under the same key. So it's isolated towards a particular contract, and this is how you use it. So now let's look a little bit more on the front-end part and how we actually use this contract. So we have a nearlib. It's our library that works with our DevNet, and it also has our integration with the wallet. So you provide the wallet URL that you use, and you also provide a contract name. So right now, a contract name is studio dash and this part, which is our fiddle that uniquely generated. But you can see in like kind of full network, you can actually deploy it under a different name, and like you can pick the name. Then wallet has access to account ID, and the account ID is either authorized or not. So if it's not authorized yet, it's going to be empty. Then we create a client, and this client connects to a wallet for signing transaction and retrieving account. And also it has a local node connection which connects to a DevNet. So it points to the URL, and URL is provided by Studio, but you can use this config. So in our case, for example, like this, you have app URL, base URL, contract name, node URL. So even so, right now it's all here. You can customize it. So if you're running your local environment, you can actually point it to a local DevNet. So then once you have an initialized client, you can load a contract. So you give a contract name and also configuration. And the configuration is view method that you can use and change methods that you can use to change the state. And also you provide a sender, and this is the person or account ID that it will be using to create original transactions. Okay, so now you have this object contract, and if you're familiar with JavaScript, you can actually debug it in a console, and this is a cool part. So it is asynchronous functions that actually interacting with a chain. So you can, for example, say hi again. It creates a promise. This promise gets resolved. It retrieves you a bunch of logs. Then some logs are already dumped into console. You can see that wallet send a log to a console as well, saying it's fine, I signed this transaction. And at the end, you get promise resolved, and you have a result. You can also do a view method, so you can say who said hi. And it also gives you a promise, and once it's resolved, it has a value, and the value is like Eugene here. So this is how we use it here. So we have a method update who said hi, and this function is calling who said hi. It checks the result, and once it's ready, it just displays it. So that's pretty much how integration with wallet works. And what I want to build today is at least modify this app to work with something more complicated. So we want to create a polling app where you can actually vote on a particular poll, unless we have some other options to see. Let's see. Okay, Rick, do we have any request for what we can build?
So far, no. I've been keeping up with questions.
Okay.
But if you guys have requests, please make them.
Token-weighted voting. I think it's even more complicated than just a plain voting. And I don't know if I'll have enough time to actually finish just a plain voting with like multiple questions that like user-generated votes. Plus, today we are not going to touch monetary transactions because they require slightly different flow from the wallet because they are not automated. So application will have to request a monetary transaction on demand, and user will have to approve right now every single monetary transaction. Okay, so I have another fiddle which is pretty similar to what I have right now. So let me just deploy it. It has a little more things that is available by the newer guestbook. And idea is we can use more complicated models for storage. So for example, there's a model.ts object which represents our data storage. And I needed to test some particular objects. So for example, array of strings that I needed. The class is currently empty. And what I'm going to do is I'm going to change this to something like a poll, which will have a few fields. So first of all, it's going to be an owner. So this is a person who owns the poll. Then it's going to be an ID. Just insert it too. Then it's going to be a question. This is a poll question, and then going to be options. And options is going to be a list of options to to answer the poll. So now I have this poll object in main.ts. I can import it, and behind the scene, what we do is we generate serialization and deserialization methods for this particular object, so you can use it as much simpler than you would have to do. And since everything is compiled at the end to WebAssembly, we have to have it and not rely on the compiler because, well, I guess we rely on the compiler, but not rely onto some library because WebAssembly is pretty much standalone binary that we're running on chain. So for polls, we will need a few methods. So let's say when you create a method, you just say, what is this? So let's say we need add poll, and it will take question and options. And we also will have a method saying get poll that given an index, it's gonna return as a poll. So this is a cool part with serialization. Since we build this, we can just return it as a plain object instead of just returning some complicated types. Okay, so it's going to be pretty similar to guestbook in sense whenever you create a new poll, we will create an object, then we need to set an owner. Owner in our case is going to be contract context sender. Then we need an index. So for the index, we're going to use latest number of messages, so number of polls. Then we just assign question and options. So we need this function. We can also export it because we might find it useful. So I'm not sure we have in a global storage whether we have inserted to. So it's still pretty rough and some methods are still missing. So if you're missing something, it seems useful, file an issue on our GitHub page. So we have a function, or we have a button there to recover bug, which redirects to studio related stuff. We can use a constant saying like key num polls. And this constant is something like num polls. And I need to return. Okay. So now when we add a poll, we actually need to store it. So to store it, what we're gonna do, we're gonna use method SetBytes. So SetBytes takes an array of U8, which is a binary array of serialized data. So in our case, we need a key. So let's say poll key, and I'm going to use poll index. And then I'm going to use poll encode. So encode is a generated method that is not, as you can see, I didn't print it there, like I didn't implement it, but we auto-generate encode and decode for poll, and this is how we move data around. So poll key is going to be non-exported function that will take an index i32 and return as a string, so we can use it as a key. And it's going to be, let's say, prefix plus index to string. The TypeScript is still pretty early, and for example, for concatenation of string and a number, you actually need to explicitly cast a number to a string and stuff like this. So some of this is still pain, but other than this, it's pretty similar to JavaScript. And the next thing we need is, once we save the object, we actually need to increase the number of polls. So in this case, you're going to use set I started to e, and it's going to be poll index +1. So we added a new poll to storage. So now we need to retrieve it. To retrieve it, we actually want to check that the index is not outside of the boundaries. So it's a simple check. We do have asserts. So what you can do is you can say assert index should be more than 0 and index should be less than get number of polls. And then you can throw a message, something like bad index, for example. So now when someone calls get poll, what's going to happen is it's going to call check index, and if assert fails, you will have an error thrown out here before you actually get continue execution. So checking early actually helps you to avoid wasting any transactions and any computation on chain that you wouldn't need. What else? Yes, so also a little bit more transaction model. It's pretty much similar to Ethereum in terms of if you start executing a contract with a change method and you throw an error or assert fails at somewhere in the middle, all changes to the state that you did before are going to be rolled back. So you're not going to change the state. While you will be potentially charged for all the computation you did before. So now how you actually return this, it can be just get poll decode, and you use get bytes instead of SetBytes. And we just have poll index, and that's it. So that's our basic class. It doesn't have any voting, but all it does is like we can create a poll and we can read the poll. So we want to check that this thing works. For this, we'll modify code. We'll announce what method we have. So we have get number polls, and we have get poll. And change method is add poll. So let's try to run it. Okay, so it fails here because it's saying index doesn't exist. Model.poll. Yes, I called it ID. Let's rename it to index. Other than this, it should be fine. I think we have some issue again with serialization. Okay, so I saw this before. I thought it works on this fiddle, but maybe not. So I'll then just change the way we do things. Let's try. So it seems like a serialization of array of strings doesn't work. In this case, maybe let's try integers. Okay, and then we need to change how we store options. So what I'm gonna do I'm gonna use similar model. How I store polls, just for options instead. Okay, so array of string of integer works, but array of options does not work. Or maybe it's only assignment here, it doesn't work. Anyway, so what we're gonna do is we're gonna rename it to option IDs. And then we're gonna store each option separately. So I'm gonna iterate on array of options and store them one by one, similar to how we do storing new polls. I'll make a function which is get number of options. So this doesn't have to be public because frontend is probably not gonna call it. Okay. So we're gonna use, we'll need a key for options, which we're gonna use option prefix. And then what I'm gonna do is I'm gonna use global storage set. So one thing we probably want to do is check that the number of options is not some obscure number. So we want at least one option and maybe not more than some number. Let's say max number of options, let's say 4. So I'll do now store options. In this case, I'll do option key num options plus I, and then it's going to be options I. And I also need to store the new number, the total number of options. So in this case, it's going to be this one. Options plus options length. Okay, let's see if this works. It seems fine. We got it to work, and I think we can store options. What I forgot to do is to put them in poll. So what I need to do, I'm creating an array with options length, and then I can just save items to something like this. Okay, so now to retrieve a poll, you would need to actually manually retrieve every single option. But this is just our problem right now with the compiler. So let's try actually add a function to retrieve an option. Similar to get poll, except we need to check option index. And it's gonna check something similar to polls, except except it's gonna check the tuple number of options. And then we use option key index, and it will, we don't need to decode it because it's just a string. Yes, so why we exporting functions? So we export functions. So main TS is our contract code. And this is the code that's gonna be running on the blockchain. So this code is currently in TypeScript, and it's kind of variation of a TypeScript called assembly script that compiles to WebAssembly. So exported functions are the functions that are gonna be available to a blockchain to be called. So for example, blockchain will not be able to call check index directly because this function is not exported. But function like get poll or get option will be able to be called. So functions by default, I think they're public, but I'm not sure if assembly script respects visibility properly. What we do is, so if you do not export a function, it's pretty much bulletproof and no other contract can call it. Then we use right now a prefix underscore, so something like get poll2. So underscore get poll2 is, even so it's exported, no other contract will be able to call it, or no user can initiate a call. But because we use in a sharded blockchain, we use asynchronous callbacks on the chain, so it's more complicated, probably topic of a next webinar. But this function will not be able to, you will not be able to call it from your application. It's gonna say this is a private method and you shouldn't call it. But your contract by itself will be able to call this function if needed as part of the callback. So let's go to the front end. Another new method that we need, which is get option, and guess we need get number of options. Let me quickly check that it's the right. Yeah. So now when we deploy the code, so what happens is because we provided this contract and loaded this contract, so now this contract is available for me to call. So for example, I can check contract get number of options and export not found. So maybe I did something that is not working. But oh yeah, so I didn't export this function actually. And that's why it's not found. But get number of polls is fine. So it's resolved and saying 0. So let's actually remove this so I don't accidentally call it. Okay. So what we can do now, even so we don't have any UI for this, we can use a console to actually add a poll. So now we use arguments. Before, all our calls were without arguments, and I didn't explain how it works. So what we did is we currently using just a plain JSON serializer for arguments. So you can say add poll, create an object, you say question, what? And then options. So this is like your answer, and you can say something like nope. And it's an array of string. So then you pretty much can close it, and it's gonna call it. Okay. Account ID is not valid. Yes, that's right. That's because I didn't sign it up with my near account. So let me do this. And now we can repeat this poll. And it's pending. I'm not sure why it's pending. Okay. Maybe it just didn't resolve it on time. Okay, so I guess I just clicked way too fast or something. On a pending promise, it was not resolved. Not sure. So it added a poll, and we can now retrieve this. So index 0, it's resolved. So I have in my object, which has index, it has option IDs. So it has indices of options, 0 and 1. It has owner, which is my account, and it also has a question. So we can also do get option, let's say 0 first, and it's resolved to 1 and 1. Aha. So we can see because of the panel. Our assert failed. So it didn't like my option 1 for some reason. So let's see what's going on. Num option plus number of options I use. That's right. And check option index. So this should be 2, unless I forgot to change something. Okay, let's basically export this function so we can debug more. And we can now retrieve this function. And we can see what's the number of options I added. Okay, so it's 2. So I'm not quite sure why it failed. All right. So the reason why it fails is because to call this function, you need to provide a JSON. So it doesn't take a single argument. You need to provide something like get index 1, and it will retrieve an option number 1. And that's how you retrieve 0. So the reason why it worked before for 0 is because on JavaScript, 0 equals to empty object. And here we just, during deserialization, and the integer became a 0 as well. Okay, so now we got functionality of the contract working. How we actually can display it is more like a UI work. So we can go to JavaScript, and here I have my function called refresh top. And this refresh top previously was retrieving like who said hi. So now I'm gonna do contract. Let's say get number of polls. And I'll start remembering my current number of polls. So at the beginning it's 0. Once it's resolved, I get a callback with the current number, or I guess new number. And I can now use this. So first I need to initialize it, like we have way too many polls. I don't want to fetch all of them. So I would do num polls 0. I'll do num polls equal to max 0, new minus 10, and then I will retrieve them one by one. And I'll do this using a loop. But I also gonna do this asynchronously, so if we run in multiple nodes, they'll reply faster. And I'll just say, for example, fetch poll. Okay, so I fetched all my polls, and now I just need to update my current number so I don't refetch them later. What fetch poll gonna do? It has an index, and this index is the poll number that I need to fetch. And this is how I'm gonna do this. So I'll do get poll index, and then I can do a callback for result. So I have my poll. I can also keep all of my polls that I fetched in the array, so I can later use them when I need to do something. So I'll save it, poll index, and I can also display it immediately, but we also want to display options. So to display it, I might need some UI work. So here I have top, rename it to polls, and have a div that I'm gonna use for polls. So it can be done much nicer if you use one of the JavaScript frameworks to actually display something like React. And I think we have some plans to do basic React components to just demonstrate how to do this later. So for every poll that we fetch, we're gonna create some elements. Name element, it's called div. And our text gonna be poll question element class list add row. So I'm using Bootstrap. So element add and child. And let's just for now verify that it works. And later we're gonna fetch a list of options. So when we don't need to redeploy a contract, the front end is updated on a save, so we can just refresh this and it's gonna work. And you can see that I got my one poll option, which is loaded. So now we're gonna fetch options as well. So to fetch options, we can use parallel fetching as well, but we're gonna do something different. We're gonna pass the element that it needs to update once it's done fetching it. And we're gonna do it pretty similar to what we did here, which is we're gonna do get option index. And here all we're gonna do is element inner text equal to so now for every element or every option that I have, I use I'll create a button for an option. add some classes. So it's a button and say primary. And also I need to add this to an element. And we call fetch option that will retrieve the option index for and populate the button once it's fetched. So this is done, so we can refresh, and for each doesn't work. Okay. So I guess I'll just await its option IDs. Okay, so that works, except it doesn't look nice. I guess because BR doesn't work for row. Maybe if I remove row, should be fine. Okay, so that's a basic UI that we just did on top of the contract. So what other feature we might want to do later is actual voting. And when you press a button, you would call a contract again to vote on this particular poll index, and also record that you're voting for this option. Then we're going to record that you voted for this particular poll, and we're not going to allow you to vote again. And we're also going to do count the number of votes per option. Okay, I think I can stop right now and just start answering questions.
As a reminder, if this is weird to hear. As a reminder, if anyone wants to ask questions live, like over voice, just feel free, and I'll promote you so that you can do that. That can be the easiest way for Q&A.
Cool.
I'm gonna start promoting people. Ajay, you're up if you want to be.
Hi, are you able to listen?
Yep.
Okay, thank you. Hey, great job. And then I have a quick question. Say we have a requirement of storing a large number of files. So because they might vary in size, and so what is the mechanism like, so we have to use the external storage and store the hash into the blockchain, or
yeah, that's
it?
probably like the best option right now, because storage on blockchain is mostly used by contracts. So if you don't need to use this file on chain, you can use a hash and just like retrieve it by the hash or by URL.
Okay.
Yeah.
Okay, thank you.
Yeah. So we had an example where we actually did this, but we used IPFS and JavaScript version of IPFS, but currently JavaScript IPFS is not working properly. Otherwise, we could show this as well. Another
question?
Yeah. Go ahead. Yeah, so main.ts is actual contract. This is the code that you first write, but then we compile it and we create some files. Like, for example, this is the file in assembly script for a model that has serialization in it and deserialization. Then we have a main near.ts that is a compiled main.ts file, which also has some serialization, deserialization, and wrappers around functions, because WebAssembly has a very limited set of types that you can use. It's pretty much integers. And then all of this compiles later to WebAssembly. So the main.wasm is actually the WebAssembly in the text format. But because Studio that we use allows us to just display WebAssembly code in text format, it's what it does. So it looks like a assembly with a bunch of functions. It actually looks pretty nice there. Even so, we cannot read it.
Well, I mean, if that's all we have, I think we can wrap it up. Let's see. Let me jump back.
Okay. Thanks, everyone.
Thanks, Ichi. And I've got like 3 different things here. All right, I'm unmuted on that. And I'll share my screen one last time here. So thank you guys, all of you. So yeah, whoops. The very end here, I just want to say thanks a lot for, oh yeah. Forgot about this little part. Yeah, so if you have questions, these are the places to go. And in the end of the day, we're moving super fast and getting things shipped. We you know, you've seen the developer experience already. Honestly, if you have an idea for something that you want to put together, if you're curious, join the Discord. You know, like we're here during the days, and our entire existence is predicated on helping you. So you know, if you have an idea that you want some feedback on, if you're curious how to use this in general, like we can at least point you in the right direction. So you know, we're friendly folks and would love to have you. So thanks a lot for taking some time this evening, and you know, I hope you have a great rest of your evening. Cheers.